because you're limited to that speed at the moment to save batteries?
No, that's. I think at the beginning it's given by the technology. What we wanted is to have an airplane which takes absolutely no fuel on board. So self-sufficient, collecting the energy itself from the sun. So when you look at it, when you look at what's feasible, you understand very quickly that you have to be extremely good in reducing energy consumption. And that's also the message that we want to communicate, is that if you use existing technology, which we have, the solar cells we have on this airplane can be bought by anybody. You can do great things, such as flying in a totally sustainable way. You can do great things, but by spending much less energy than what we are used to normally in our normal way of life, where we take it for granted that the fuel is there. We take it for granted that there is always fuel at the petrol station and that it's cheap. And this is not forever. And we have to start to think about what should come next there, because if not, we'll be caught in some kind of a difficult situation. So when we started to work on this project, we really realized that this should be a good demonstration of what can be done. But of course the challenge in the air is enormous. If you miss it slightly, you can't fly. So the judgment is, in some ways, is terrible. If you have a car and the performance is not so good, you go a little bit slower. If you have a board, the performance is not so good, you go a bit slower. But the airplane, exactly, you are
and because of the night,
on the ground there.
Because of the night, this is the non-return point. If you start the beginning of the night, you need to be able to go to the next sunrise. Otherwise, if you have an airport, you land. If you have no airport, you crash. And if you fly faster than this, if you fly faster than what we do now, you make more resistance, you need more energy to be able to compensate, and you will never make it through the night.
You also need more batteries probably, which makes the plane heavier.
Exactly. And it starts to be a vicious circle.
No, it's just wondering.
And what does your electrician chief says about the fact that electrician most of the time only trusts power that they can anticipate and power that they can actually predict? Because here we're totally dependent from the sun.
Yes.
So the sun is there. You have a flight plan. You have a great Belgian weather guy, Luc Truelmans, to guide us through the clouds, etc. But this is all prediction. So you're not totally free of your movement like any regular airplane. So what are the consequences? Of course, if you leave the sky, you have massive clouds coming up, and you have to make an emergency landing. So for the moment, you're streamlined, I would say, between boundaries, right?
But
yes and no. Yes and no.
Exactly.
Okay.
I'm sure we're going to answer this. Go ahead. It's the boundaries that made you react. Go ahead. Go ahead.
Give your answer, then no problem. Then I give. We may come from different angles.
Yes. In a normal airplane, you are more free, but during a very short period, because you have a limited endurance because of your fuel. So for a couple of hours, you can do what you want. We have more limited freedom in terms of action, decision, speed, and so on, but we are not limited by endurance. This airplane theoretically can stay months or years in the air. You know? The pilot, of course, couldn't follow, but the airplane itself could fly perpetually. So we have no limit of time, and if we cannot turn left just now because there is a thunderstorm, we can turn left maybe tomorrow or after tomorrow.
Okay. Fair answer.
You have the same answer?
No, but I like it.
So what's yours?
No, you're right to say that we have prediction, but we push this prediction to a very high level of sophistication. So we have a simulation model which we developed over the years now, which flies like the airplane, but in a virtual way. So calculating how much energy we collect and including the meteo, the real meteo, the forecast of the meteo. And so this allows us to play a lot of flight strategies in advance and find the optimum and modify it as soon as the new forecast arrives. So normally the meteo is extremely precise, I would say 48 hours in advance. 5 days, 5 nights, that's more difficult. So we always know, in fact, what will come 2 days in advance. So it allows us to do what Bertrand said there. It allows us to wait, maybe, or to take another direction, to go back and to wait there. As we are totally independent from fuel, that's not a problem. So the strategy is different, the paradigm is different. So we have to think also in a slightly different way when we fly the airplane.
So in a way, the pilot or the person in charge must be more clever than the regular pilot, perhaps, because I feel maybe current pilot might be a bit too much, might have a confidence issue for the moment, right? Maybe they rely too much maybe on technology or.
Don't criticize the actual pilots. He's also an actual pilot.
I don't, but I fly myself. No, I'm just saying.
No, the difference. I mean,
I'm only a normal pilot.
The difference, I think, is that we work very closely with the team on the ground.
Yes.
And there is a need to develop a very strong, trustful relationship between this team and the pilot.
Of course.
Because the pilot may have to take an action which is not necessarily what he would do with the information he has, but which is the best action based on the information that the ground has. And this partnership is extremely important, and that's what we work on since already many years now. And that's interesting, and that's what you also said a little bit. The normal pilot maybe will follow, because normally he's acting by himself, and really we need to act as a team.